My name is Siti Najihah binti AJEMAN.
My name is QASHRINA BALQIS binti JAMIL.
My name is FATIN IZZAH binti AHMAD HASBULLAH.
Least square method, exponential smoothing and moving average are used for forecasting pharmacy sales in this study. This study is to determine a model that fits the pharmacy data and identify which method is preferable by comparing their error using root mean square error and mean absolute percentage error. Then, predict the future sales of pharmacy for the next 5 years using the preferable method. In result, QWERTY is the preferable method because it produces the smallest error. Sales show that the goods or services owned by a certain person are exchanged for a certain amount of money or with other related items. Curve fitting is the process of describing a model that offers the greatest fit to the specific curves in dataset in regression analysis. LSM is a line of best fit to describe the possible link between independent and dependent variables. ESM is a time series forecasting method for univariate data that can be extended to support data with a systematic trend or seasonal component. MA is a technique for determining overall trends in a data collection that is an average of any subsets of numbers. Most pharmacy groups have led to inventory shortage or oversupply, both of which can be detrimental. Product shortage undermine customer confidence, reduce profit, and provide competitors with unique opportunities to close market gaps. On this research, 3 methods will be used in this study to solve the model for sales, namely least square method (LSM), exponential smoothing method (ESM), and moving average (MA). Even so, the study on the comparison between these 3 methods have been last conducted by other researchers for forecast the pharmacy sales. There are 3 objectives need to be achieved. First, to determine a model that fits to the pharmacy data. Secondly, to identify which method is preferable for predicting sales of pharmacy by comparing root mean square error and mean absolute percentage error. Lastly, to predict the future sales of pharmacy for the next 5 years from 2022 until 2026 using the preferable method. This study focuses on the regression analysis approach of reducing the sum of the offset or residuals of data from the display curve to determine the best fit for a dataset of pharmacy sales. By using MATLAB, Minitab, and Microsoft Excel, implementations are included to show the curve fitting. The limitation of the study is there were only a few studies conducted on the same topic. The limitation contribute to our limited knowledge about pharmacy sales. For significant, predicting sales of pharmacy for the next 5 years to enable continuous strategic planning. This research puts some focus on the pharmacy's ability to handle sales changes according to the new scenarios such as COVID-19 or inflation. And for benefit of the research, continuous forecasting allows organizations to respond to failures that are exponentially reduced to today's market rate.
Firstly is least square method. Least square method is a statistical procedure for finding the best fit for a set of data points by minimizing the number of offset or residual points from the plot curve. The model is employed in basic linear regression by using formula linear. In general, the predict value of y may be modeled as n degree polynomial where coefficient is parameters while s power of 2 until s power of n is independent variables. We assume that the best fit for a set of data points is an exponential function of the form is given by this formula, where the constant a and b are unknown. Second is the exponential smoothing method, which is single exponential smoothing SES. SES method shows that weighting decreasing exponentially as observed data. We choose a fixed value alpha is 0.9. The equation is as followed by this formula. Next, double exponential smoothing utilize a level component and a trend component. This approach as a fixed alpha 0.9 and beta 0.3, the equation for double exponential smoothing are as followed by equation obtained. Moving average MA, which is simple moving average SMA. SMA is the simplest form of an MA and is produced by taking the arithmetic mean of an given collection of data over a specific time. The formula for calculating the SMA is as followed by this formula. Next, exponential moving average EMA lends greater weight to resale price. The formula is as followed by this formula. Next, weighted moving average WMA is computed by multiplying the provide price by the corresponding weighting and adding the results. The formula for the WMA is as followed by this formula. The author in 2016 predict solar energy using LSM. In this research used to predict solar intensity as dependent variables and month as independent variables. Next author is in 2010. This research claimed that the prediction models derived using this method outperform past predicted futures model and a simple model based on sky condition forecast from period 1. Lastly, the author in 2015 using LSM in research to predict the number of students who enter in private college. The author claims the profile prediction model is valid results. The authors in 2014 compared two forecasting methods, namely projection trend method (PTM) and single exponential smoothing (SES) to predict pharmacy sales. Next, the author in 2016 studied pharmacy sales with cross exponential smoothing. The prediction is based on the algebraic sum of the previous forecast and a percentage associated with adjustment error. The authors in 2015 provide the findings of a medium-term forecast of cloud computing providers using exponential smoothing approach. The authors in 2015 attempt to predict sales using the single moving average, while the author in 2014 attempt to predict sales using the weighted moving average, which only applies to one or a few products rather than predicting many products.
The framework of this study is mainly divided into some parts, starting with the problem identification, followed by the data description part using the model identification. In the next part, the model identification could be achieved with the aid of using the use of LSM, ESM, and MA. Lastly, the result measured based on error comparison by comparing the error and performing prediction. The data are secondary data that was retrieved from Pharmacy A and the report data from the official website. The data used in this study were imported consisting of tables of revenue transactions and detailed sales from 2000 to 2021.
This table shows the value that we use to solve the LSM function. To get the function, first we form a matrix to get the C0 and C1. We need to substitute with the values that we get from the table. Then solve the coefficients. From that, the linear function is created. For quadratic, we find C0, C1, and C2. For cubic, we find C0, C1, C2, and C3. And for quartic, we find C0, C1, C2, C3, and C4. Then continue to the same step as linear function. Lastly, the function is created. As we can see the general equation of exponential, we need to linearize the data to find A and B. Table shows the values that will be applied for exponential function. After we linearize, we continue to the same step like before. Then we get the C0 and C1 values and solve it. From that, the exponential function could create.
The equation single exponential smoothing can be obtained in equation and then forecast by using a fixed alpha 0.9. The value of actual and forecast data from 2000 until 2021 are shown in table. These are a few examples to calculate for 2001, 2002, and 2003. The equation double exponential smoothing can be obtained in equation to forecast by using the fixed alpha 0.9 and beta 0.3. The value of actual and forecast data from 2000 until 2021 are shown in table. This is a few examples for calculate for 2001 until 2003.
The value for forecast data can be obtained by using SMA formula for 2-year SMA and can be shown at the table from 2001 until 2021. These are the examples to forecast the data for 2002 until 2004. The value for forecast data can be obtained by using EMA formula for 2-year EMA and can be shown at the table from 2001 until 2021. These are the examples to forecast the data for 2002. The value for forecast data can be obtained by using WMA formula for 2-year WMA with the weight 0.1 and 0.9. This can be shown at the table from 2001 until 2021. These are the examples to forecast the data for 2002 until 2004.
The equations of that have been achieved using manual calculation and MATLAB software. From coding, we get the equation and graph for linear function. Next, we can see this is quadratic equation and graph function. Followed by cubic, quartic, and exponential, we can see the general equation obtained from coding in MATLAB and also get the graph function. From the comparisons, it is found that 4 results are valid, which is linear, quadratic, cubic, and quartic, and 1 result is invalid, which is exponential function.
This figure shows different alpha values are used to determine the best alpha value for predicting sales by using MATLAB. When alpha is close to 1, deepening is with, and when alpha is close to 0, deepening is low. In result, the best value for alpha is 0.9 since the alpha is close to 1. This figure shows the curve fit and forecast of SES with fixed alpha which is 0.9 using Minitab. The reason we use the alpha is because the larger alpha can cause the line approach to actual value. The figure shows the curve fit and forecast of DES with fixed alpha and beta which is 0.9 and 0.3 respectively using Minitab. Smaller value of beta considers long-term trend and larger value focus on short-term trend. In summary, DES is more preferable method compared to SES since the alpha value close to 1.
This shows that different years are used to determine the best value periods of MA for predicting sales and to know which period tends to be more responsive to recent value sales. When the value of period is small but greater than 1, MA tends to be more responsive to the actual value. So, the best value periods of MA is 2 years because the period is small but greater than 1 for SMA, EMA and WMA. This shows that different weights are used to determine the best weight of WMA for predicting sales. A WMA is a type of moving average that puts more weight on recent data and less on past data. When the weight is greater on recent data and less on past data, WMA tends to be more responsive to the actual value. So the best weights for WMA is 0.1 and 0.9 for 2 yearly WMA because the weight on recent data is greater and less on past data. The values that have been achieved using manual calculation and Microsoft Excel were found to yield the same results. The curve fitting for MA is shown. The forecast produced seems similar and difficult to identify accurately. Hence, to avoid this confusion, RMSE and MAPE was adopted for proper verification.
To calculate the error rate of the prediction using formula root mean square error RMSE and mean absolute percentage error MAPE. The table shows the comparison error for least square method. We can see the critique is accurate for this method. It has a smaller error in RMSE and MAPE. The table shows comparison error for exponential smoothing method. So that the double exponential smoothing is the best method that can be used for forecasting because it has the smallest error compared to the single exponential smoothing. Table shows the comparison error for moving average. We can see the exponential moving average is the best method because it has a smaller error value in RMSE and MAPE. The comparison from three methods, we finalize critique, double exponential smoothing and exponential moving average have the smallest error. So we do comparison error and the study revealed that critique is closer. Hence, it can be said that critique will give a better forecast for pharmacy sales.
For forecasting the next 5 years, we use critique method since the errors are smallest. The table shows the value of forecast sales from 2022 to 2026 and implement using Microsoft Excel. The forecast data shows an incline that might be caused by several factors. The first factor is price war between the retail pharmacy. This is related to the pharmacist's inability to estimate future income due to the continuous and sometimes consecutive fluctuation in medicine costs. Next, the current condition of the economy could give a direct impact on the pharmacist's income.
For the conclusion, the three objectives have been solved. The first objective has been achieved by determining the models which are LSM, ASM and MA. The second objective achieved by comparing the RMSE and MAPE for the three models, while the third objective achieved by forecasting using preferable method which is critique method. The recommendation for the next study is Box-Jenkins based RAHMAH model, Euler method and Ranch-Keta can be used to make prediction of pharmacy sales. Next, use larger data to make the curve fitting smoother for forecasting. And lastly, the error for three methods could be calculated by using obsolete error for future study.